So, Silvia, your area of research is quantum mechanics. Can you start off by telling me a little bit about what that is, and then what you're doing with this fantastic piece of equipment here?
Okay, yeah. Quantum mechanics is the branch of physics that describes the behavior of matter at the microscopic level.
That's atoms.
That's atoms and molecules, yeah. What we do here, we have an experiment where we try to observe and control the quantum behavior of atoms. In particular, we are working with rubidium atoms.
Why particularly rubidium?
Rubidium is just very suitable for the type of experiment that we want to do. We can use techniques called laser cooling to slow a gas of rubidium atoms down and make it interact with lasers for a long time.
Why is it important to cool the rubidium atoms down? Why do they need to be so ultra cold?
Well, because what we do is we start with a vapor of rubidium at room temperature.
That's gas?
Yeah. And at that temperature, obviously, atoms move around really, really fast, 300 meters per second. So you don't have the time to let them interact long enough with laser beams, less so to observe them, to observe their quantum behavior. So what we need to do first is to bring down their temperature so that they are actually very close to absolute zero, and they are virtually frozen, so that we can then manipulate and observe them.
So are all these lenses and things on this table, are they to kind of bounce the lasers around?
Oh yes, all these lenses actually serve a purpose. If you were just to remove one of them, the experiment wouldn't work anymore, so please do not touch. Yeah, they are used to shape the laser beam, to control the intensity, the frequency of the laser beam, and the polarization, and so many other things. So everything has to be just right as it has to be for the experiment to work. So just by removing or tilting one of these mirror or lenses, the experiment wouldn't work anymore.
So, Silvia, quantum mechanics, it's clearly fascinating in itself, but does it kind of have any use in everyday life?
Well, yes, there are already uses of quantum mechanics. You may think about the lasers that is widely used in several applications. What we want to do here is to study and control cold atoms so that one day they could be used, for example, to be the fundamental components of so-called quantum computers, or to form ultra-sensitive devices like gravitometers that could detect a person walking by in this room or the volcanic activity.
How does the research that you do here feed into your teaching?
Okay, well, this is obviously cutting-edge research. We are at the forefront of researching cold atoms and quantum mechanics. But I can imagine that the results we will obtain in the lab and the research we do here will feed and inform future quantum mechanics course at the Open University.
Silvia, thank you.
Thank you.